Hello. Today I will tell you about how to differentiate y equals arcsin x function. Okay, but before talking about it, let me tell you how to differentiate this function implicitly. Okay, you already know differentiate this function explicitly, so that's gonna be ty over tx equals 2x. Okay, I differentiated this one explicitly. However, if you differentiate this one implicitly, you can think of y as a variable, okay? So when you differentiate this y variable, differentiate first, so y is going to be just 1, right? And then add ty. And if you differentiate this variable, there's x variable, right? So that's going to be 2x, so add tx. So you can divide both sides by tx, that is going to be ty over tx equals 2x, right? Or you can skip this step. If so, when you differentiate y variable, that's 1, so add just ty over tx or y prime. And then that's going to be 2x. Done, right? One more example. If you differentiate this one, that is representative equation of soccer, right? So this is sort of an implicit function. So if you differentiate this one, x variable, that's going to be 2x, right? Plus, and 2y add ty over tx. And that's going to be 0, okay? And then ty over tx, you can express dy over dx, right? That's going to be minus x over y. Done, right? Okay, so now I will tell you how to differentiate this function. However, most of the students, they have no idea how to differentiate this one at first sight, right? So if you think about it, okay, so the arcsin function, right? So we can rewrite this one like sine y equals x, right? Because f of a equals b, then f inverse of b equals a. That is going to be very important properties, right? So anyhow, sine y equals x. And then you can think of right angle triangle. So y, this angle is going to be here, right? So this is opposite. So as you know, SOHCAHTOA, so sine is opposite over hypotenuse. So suppose x and hypotenuse equals 1. So okay, sine y equals x over 1. Perfect, right? And then by Pythagorean theorem, you can get adjacent 1 minus x squared. Okay, and then we will differentiate this one implicitly, as we have learned before, right? So if you differentiate sine y, that's going to be cosine y, right? So I differentiate y variable, so you can add ty over dx. And if you differentiate x variable, that's going to be just 1. So ty over tx is going to be 1 over cosine y. And as you know, cosine is so adjacent over hypotenuse. So cosine y equals just square root 1 minus x squared. Okay, now we got the result. So if you differentiate y equal arcsine x, that is going to be 1 over square root 1 minus x squared.